Alantuck, nice to see you.
You sound surprised.
We're being set up for YouTube Live on the e-NABLE YouTube channel. Okay, and we are streaming and live. So let the meeting begin. This is November 6th, 2025. Bionic Design Meeting. Vivek Badami is our host. I pass the torch to him.
Hi, thanks, John. Yes, this is our monthly forum meeting on bionic design. So we try to get people who are doing the bionic devices at affordable costs. And so we're more than happy. We're excited to have Eric back. He's given us quite a few presentations before and he's got a lot of exciting stuff today. So thanks, Eric, for making the time.
No problem. Okay, so I'll just dive right into the live technical demonstration that will probably collapse and fail miserably. So you should see another screen there. That's my pixel view, so we can show you this. So this is the hand that I've been working with, that I've been playing around with. This is something called the Amazing Hand from Pauling Robotics. It is an open source design, completely free for anybody to use. It's designed as a robotic end effector. So that's why it's only got 4 fingers. They designed it to run off of Python, actually not off of Python, off of some of their own software libraries from a PC or a Mac. So what I did is I took the design, I 3D printed it. The pieces that you see, these are all PLA. And then these fingers all have shells on them. So this is just a TPU shell that you can peel off. So the underlying piece is kind of like a exoskeleton, for lack of a better term. They've got some metal rods that they use inside of to do the pivot points for the joints. I just changed the hole size a little bit. So I'm using 3D printer filament instead. So making it a little bit simpler, a little bit cheaper, a little bit
That's how we
easier.
roll. Yep.
Yep. The servos that we're using, these are serial servos. These are different than any other design I've seen e-NABLE use. These are serial driven, so you can daisy chain them all together and run them off of just a serial bus driver. So all the wiring in here, there's lots and lots of servos. Each of the fingers actually has 2 servos that go along with it. So the servos can actuate at the same time to pull the fingers closed or open or whatever position you want. But they can also, if you activate one servo at a time, you can get that side-to-side motion as well. So you can do all that. I cannot show you that today. I don't have that programmed in, but I can show you opening and closing, hopefully. All of the wiring kind of fits inside of here. So this is very quick little box I just 3D printed last night. You can see all the servos. Let's see if we can see that. There they all daisy chained together. There's a lot because there's 8.
That is a lot.
2 for each finger. And then they are all driven by this little bus, this little serial bus driver. So all you need to do is plug in basically a USB-C and a DC power jack. So it's pretty easy, not too hard.
It's interesting that they're shaft driven, not cable driven.
Yeah, so again, this is coming from robotics, where they know shaft driven, they know linkages, and you do get slightly better, more predictable opening, closing over thousands and thousands of cycles because you're not stretching any kind of tendons or anything like that. So less chance for a string to break as well. So I've been playing with these a little bit, playing with this design. There are shells that go over the palm and on the back.
Excuse me. Sorry, excuse me for a second. So when you said shaft driven, what you were pointing out was the shaft that goes from there to there. Okay. And all of the servos in the wrist are doing what?
So there are no servos inside of the wrist.
So what is that bank of devices we see there?
Those are just the wires for the servos.
Got it. Okay,
So these servos
got it.
coming through, this is just wire inside of here.
Got it.
Yep. Um,
Okay.
Other thing about the design, so if you can see it with the thumb finger, the thumb is locked into one position, so it
Hmm.
doesn't rotate around, but it's all linkages here as well. So this is all set distances, right? We're
Hmm.
not doing anything there. Plugging everything together. Once you get all this wired up, all this wired into here, there's just two plugs that go into my control system, and my control system is an Arduino right now, just because I had one laying around. So it's an Arduino 4. I hooked it up to, so this is just a little bit fancier for development purposes. There's a battery pack in here. So inside of that battery pack, that's what's running the servo power and the Raspberry Pi. And the Raspberry Pi, I've hooked up to a touchscreen. So we'll let this zoom, we'll let this start up. So there's the Pi. The thing I like about this from my teaching experience, what students really struggle with is soldering and getting good connections from soldering. This is no soldering. This is plugging in wires and then doing a bunch of software stuff. So on this, I plugged in a touchscreen to it, just hooked it up because why not? So we'll open up this little app that I wrote for, called it the Amazing Hand. At some point, I'll release this online. And here you can see the user interface. So it's got a touch interface, and all you got to do to make it work is just touch the button. So whatever button I touch, I can do any of these poses. So we'll show you the finger opening and closing.
Nice.
Tripod grip, middle grip, ring finger, pinch, piece. So we can go through all these poses just by touching the touchscreen. We could move this over to be controlled from a Android app or iOS app or something like that, so you control it from a phone instead. That would just be a little bit more development work. And then also, we'll see if this works. There's another tab in here. I don't know if you can read it. There's a voice tab.
I see that.
Build all of this, the software.
Yeah. So I wrote all the software for this from ChatGPT and vibe coding on a weekend. So we've got this voice control that we can do, and we can start it listening. And all the voice control, this is all running locally on the Pi itself. We're not going up to any online servers, anything like that. It's all just running right here. I think it's Whisper for voice recognition. So we can have it start listening. And it actually does a pretty good job. It tells you what it hears. So it's translating everything that it's hearing. So you can see what it's hearing right there. My phone would focus. But if I want to close the hand, close, open, pinch, middle, open. So there you go. And that's all running all locally on the Pi again. We can stop listening. I like to use the touchscreen more. I did test this at an event. It does need some work for the voice control for things like crowds and recognizing children's voices and women's voices, not 40-year-old white guy voices. It's really good at that. But that's what everything's been trained on, so that makes sense. So yeah, that's what I've got. That is the Amazing Hand. I'm open to any questions, talking about anything else that anybody wants to talk about.
Oh, this is great.
Well,
I have a question, Eric. So the Amazing Hand, what is that? Is it design on
Yeah.
Thingiverse or
So it is
what is
not
it?
on Thingiverse. It is on GitHub. Let me look it up. And Pollen. It's a robotics company called Pollen Robotics. It's a French company, I think it is. They have a variety of robots that they do. And this is just a project they've been working on, and they were like, "Wow, are we going to sell this?" no, let's just release it open source and see what cool things people do with it. So this came out about 2 months ago, and then I had some time over I think it was Saturday that I had a little bit of spare time that I wrote up the software to do this on a Pi.
Do you know how heavy it is? Oh, sorry, did
I
that
have not weighed it. It's not too bad. It's comparable to some of the other e-NABLE designs, Bionics designs that I've assembled over the years. I can get a weight on it. I'm thinking if we wanted to really lower the weight, a couple things you could do with this design. I think you could get away with just 3 fingers. Maybe put in another servo to rotate the thumb, and then really optimize for 3 fingers. You can do pretty much anything you want to do with 5 fingers with just 3.
Well, I was actually thinking instead of having 2 servos per finger, because it's discrete selection, we could
Sure.
have like a selection, like either on like a solenoid or something small.
Sure. Yeah, all sorts of things you could do with it. Yeah. And I'm
So,
open to
Eric,
trying anything. Yeah, John.
how does the grip feel? How much strength does it have?
So I've played around with it at home. I use it to grab a bottle and drink from a bottle. So a full bottle. Pretty good.
Okay, so if you shake hands with it and you ask it to grip, it doesn't crush your hand, but it gives you a good firm handshake.
Yeah, yeah.
Cool.
It's not going to crush your hand, but you'll feel it.
And what are the material costs for the components?
Okay. So component wise, it's probably a total of, oh gosh, I did add this all up. The Amazing Hand itself, just to build it, as they've documented, is about $250. Uh, Biggest expense there is in the servos,
Sure.
because you can't use just the cheapest possible servo. These are slightly nicer. So a pack of 10 servos was about $110. I think that was a little bit more expensive than usual, again, because of tariffs. So I think there was a little bit of increase there. But otherwise, that's not too shabby. And then the Pi itself, I think I had this one. I think I got it when it was about $80. And the prices on those again are fluctuating. And then the touchscreen I think was like $40. So probably about $400 total.
Yeah, which is certainly reasonable, and B, a miracle.
No,
So
not
C,
that. Yeah.
right. So I'm just in practice, you would probably have a glove over the palm as well. And I'm just wondering if that would interfere with the shafts on the servos, and what it would feel like if you were shaking hands with one of them.
So what they also have, I didn't bring them with me because I completely forgot. I haven't been using them because I've been iterating on it. It does actually come with TPU shells that you 3D print, and that kind of covers up all the linkages.
Cool.
And then you could stick a glove over that, no problem, because that prevents any kind of collisions with any of the servos and wiring in there. And then I should test it and see how it feels when you actually interact and hold it and shake hands and stuff. Yeah.
So this seems like a very much more sort of robust and hobbyist friendly kit than I think anything we've seen along these lines before. It looks like the assembly doesn't seem too challenging, and there's no soldering.
No soldering. The assembly, the one trickiest part of the assembly, and I would need to work on the design a little bit. So it's tricky down in here. If you look at the servos, you use the servo horns that come with the servos, and you actually cut them down, and screwing these little holes, these little kind of ball joint linkages into those little servo horns. That's a little tricky. You see there's a little spacer here to
Hmm.
get the exact right distance between these two linkages. These are commonly used in animatronics and like hobbyist animatronics. There's a little metal bar that you have to put in there too, and you have to cut those little metal bars down. That requires a piece of like a wire snippers don't work. You need some really decent cutters to cut that down. And then some of the screwing things in a little bit. I think there's some optimization that can be done here to get rid of some of the hardware. Like I
Mm-hmm.
think we could change the 3D model a little bit and get some nuts inside of here, some heat inserts maybe, to
Even
get
just a
rid of
rivet.
some of the metal bars or rivet. All sorts of things you could do.
But the linkages are all identical, correct? All 6 of those.
Yeah.
So the reason I ask, John, am I cutting you off?
No, not at all.
So I have kind of this larger question. So I guess I've been in and out of e-NABLE for a long time now. And one thing that always is tricky is that we always have 30 to 70% of a project. And I'm trying to do some work with the Medellin group in Colombia, and there are STL files, no native CAD, and some assembly information. And the STLs, the meshing is also not ubiquitous across all of the files. So even converting back to step to make edits is dicey. And I was thinking it would be great if we had one hand that we kind of championed end to end, full set of documentation,
Hmm.
and kind of served as kind of the template of this is the standard of what a hand or of what a device should have for both documentation for edits, reproducibility, but also design decision making. So it's like, why did we use this bolt versus this nut or something like that? And I guess I'm curious if you think this hand would be suitable for that once we kind of made changes to it, because it sounds like a lot of the stuff is already there. And then just like spitballing, what could be nice, I know that you hate soldering, but we could actually go
I'm
ahead.
good with soldering. I've just noticed when I was teaching, my students really couldn't do it. So yeah.
What we could do potentially is if we wanted, right, we could have the hand be a dev model version, so to speak, which is like plug and play, like what it is now with a board.
Yeah.
But we could also have one where we eliminate all the connectors and make it all through hole. We could make everything surface mount. We can make, instead of having an Arduino, we could have everything in the wrist basically itself, or like much smaller form factor.
Yeah.
This is part of a larger conversation that I've had with people, and I'm sure you're going to nod your head, but there's a large number of half-baked, two-thirds baked projects, and a seemingly infinite number of people who want to help. And my thought is, if we're able to take this and kind of outline what tasks need to be done, we could, yeah, because what you have functionally is better than what Open Bionics, right? They're still in the pipeline from even being able to do verbal commands. Like their hand is, I think, John, I think you were in that meeting this summer when they were saying they're like a year or two out from being able to do that.
I wonder why that is, because they're so good at what they do.
I assume it has to do with the fact that like once you sell something, your world is very different. When you give it away for free, it's actually you move quite
I
fast.
think that's right.
Yeah. And voice control is not easy. It is, right? It's getting better. It's getting easier because the algorithms are getting so much quicker with machine learning, that it can recognize lots of voices and do things a lot better.
What is the battery life on that like?
I don't know. I have not assessed that yet.
Do you know what battery you're running?
I do. Let me see what it is. It's a couple of 18650s that are inside of. Let me see if I can disassemble this box for you.
I can look it up. I don't want to make you pop it all open.
No, it's easy. So the screen just pops right off of there. So that's the Pi and the
Okay.
screen. I think you could run this on a smaller Pi. Again,
I mean, we could run it just on a PIC. right? That
Yeah.
would be the optimized form factor.
Yeah.
It's just
Yeah.
Hmm.
So this is just let's see, lithium ion battery pack, all in one, talent cell. What is it? 12-volt DC output. I think it's two 18650s in there. There's
okay.
some charging circuit, protection circuit built into it, and it all just functions off of a switch. Let me see if I can pull this out. Should
Yeah,
be able
my
to.
kind of larger question, and this is to everyone in the group, is I just feel like every 3 years or so, every 3 to 5 years, we end up
Mhm.
there ends up being right. It was right now it's like Eric Bubar. It's this summer, and also in parallel, it's the Columbia team. I remember when it was Skip was working on a motorized hand that I can't even find full documentation on. There's like so
Oh,
many
that
people.
documentation is available. That's the Moto Gripper, and
The
it's
Moto
on the
Gripper,
hub.
yeah,
Hmm.
but it feels like I don't know.
No,
I kind
absolutely, you're absolutely right.
of
So let's do talk about that a little bit. We've had design teams and sprints in the history of Enable, and I'd say, ones where, for example, people like us from the town hall, and in many cases, old timers like Jeremy Simon, who's pretty much retired from Enable now, get together and meet every week or two. And, the I think the Phoenix, if I remember correctly, the Phoenix came out of that, um, as did a few other things. It's hard to do. We haven't done it for quite some time. What it takes, David and Eric, is a couple of committed technical champions who will carry the torch, both in terms of organizing the meetings, doing the brunt work of organizing the people, and frankly, doing most of the actual integration. As you know, you need a product manager who typically also is a tinkerer. And then there are a lot of people who would love to be a part of it and put in their 2 cents. We haven't had that for a while. On the other hand, this could be an opportunity. Let me mention a couple of other things that come to mind. Well, one is, Eric, I'm eager to get an update with you, but I want to introduce a high school student named Rishab Ray, who gave a presentation here, I think a few weeks ago, who did a remarkably good job, especially for a high school student. But I, I wouldn't have been surprised if he said that he was a young-looking uh, ABD. He's really, really good. And he developed a really nice modular system for using AI pattern recognition for interpreting EMG signals. And he just applied to Hopkins undergraduate. And he's applying also to UCSD undergraduate in bioengineering. But he's got a system which is already very interesting. And for all the reasons you mentioned, Eric, I'm not sure that voice is really the right solution. In the real world is noisy. Voice is cool, but something implicit that can be controlled. And EMG, or as we've tinkered with in the past, mechanical muscle detention from, for example, forearm muscles may may be the right solution. So anyway, Eric, you've been introduced to Rishabh. He's going to write you, and I highly recommend him. And David, are you proposing to be the guy to say, I'm going to pick up the flag and run up the hill with it? Who wants to follow?
totally
Totally. Is that right? You're in a,
unequivocally.
huh. And Eric, do you think that this might be the right platform? Because it certainly seems more sort of modular and plug and play than what we've seen traditionally.
Yeah, I think it's closer than anything else because I've made all the Bionic designs when they come out, and I'm like, this isn't quite right. This isn't quite right. This isn't quite right. This gets
Well,
a little bit closer, I think. Um,
Vivek, you've seen all of these by now.
yeah.
Does this seem like the right hill to try to conquer?
Yeah, absolutely. To back up, I think I really like David's point about sitting on one design and using it as a test bed to do all sorts of stuff, sensing and pattern recognition, etc. Um, and in terms of designs, this is really nice, Eric. I think you also had a sort of a test bed approach when you were at Marymount. You had talked about another gripper. I forget which one it was, but that seemed like almost sort of like semi-completed as a potential for being a test bed. I don't know if that's you would prefer this over that, or what your
Yeah.
thoughts are. But
So
and then
so
the
the
third,
yeah, go for it.
sorry, to finish that, and definitely, I think getting Rishabh in touch with Eric and seeing how that the EMG sensing and pattern recognition can be integrated with this hand would be great, because I don't think Rishabh really cares about what the particular manipulator is. So, yeah.
Right. By the way, Rishabh has taken the bait, and he actually spoke to one of the Meta engineers responsible for the new wristband device that they produced. And he said they hadn't really thought about that application, but he was quite interested. But he began to say you'd need FDA approval, et cetera, et cetera. I began to break him into the whole open source frontier mentality. I began to coach Rishabh on how to advance the notion that, well, if you do it with a volunteer community and you have an amputee as a collaborator, not as a patient, you can actually get a lot done quickly. And then if you come up with something robust, someone can then take it to the FDA, et cetera, et cetera. I think it's probably and that wristband looks like it would be a very interesting detector for this kind of thing also. All of which is to say, um, it's an interesting collection of people and technologies emerging right now. Eric, I'd like to know a little bit more about your new circumstances and what you're doing, because there's a new Eric Bubar in town, and he's still tinkering, which is just great to see. But tell us about the new Eric Bubar and what life is like after Marymount.
So I am still tinkering, and I have a lot more resources and learn a lot more and access to a lot more people that know how to tinker with stuff here.
And
I
remind
can't.
everybody, here is for you,
So
Hopkins
right
Medical
now,
School.
new job, I am at the Johns Hopkins Applied Physics Lab. So this isn't a teaching position. It's not a research position. It's doing projects for whatever is funding said projects.
Hmm.
I can't say more than that.
Okay.
So I could tell you, but then I'd have to kill you.
Well, that's right.
Uh,
Well, listen,
I'm
I
I'm
do
actually at
know that
work right now.
that lab has been funded by the Defense Department for a long time, I think.
Yeah, yeah. Amongst other things, there's tons of different projects going on. I'm doing a lot with immersive technology, so VR and
Hmm.
AR, XR. I have tried the meta glasses, the display glasses with the the EMG band. Those are interesting. Um, there is an so I've talked to people both at Meta and outside of Meta about how to get access to that data for those EEG bands, if they're going to open source that or make it available to do further development on for other use cases. Right now,
Hmm.
they aren't planning to release an SDK for the EEG band itself,
Interesting.
but maybe at some point. There is another company that is actually producing the same kind of technology, EEG band. That one's more open, and you can use that with smart glass platforms. Um, I've thought about that as maybe an avenue to do some of this work too. Nice part about that is it's a lot of the smart glasses are really focusing on getting good AI into it and recognizing what you're saying, recognizing what you're seeing, so you can start to do some not just um, single input information using something
Hmm.
it's called a VLA. It's big in robotics, a vision language action model. So you teach robots how to do things much more effectively if you show them what to do and tell them what to do, and then show them what the action is. So you can start using some of that to teach these hands how to do things. So stick a camera in the palm and it sees something, it recognizes that thing. You can have it recognize your voice maybe, or sounds, or whatever, and it can use all that context to learn how to do things. So you don't even need muscle, but you can add that muscle in as an additional source of information, and really teach these things to do things really, really well. And you can do it on slightly more powerful platforms. So you can't do it on like a Arduino Uno. That's probably pushing it. But these Raspberry Pis, I haven't played with the Arduino Q, I think it is. That's a little beefier. Some of these Chinese companies like Seed Studios, doing on-device machine learning and AI recognition stuff, some of those might be interesting platforms to play with. But again, going back to David and Vivek, what they were saying, I think you want to choose something as one development platform that people can build on. And I am leaning towards the Pi being a better source for that. You don't need tons and tons of sensors that are easy to plug in. But if you want to start using some smarter algorithms and using some more mature software development tools, I think the Pi gets you into those, and then you can do a lot more. So I think this is a good starting point. I don't know that this is the exact platform you want to build off of. I did post a link to their Git in the Slack, so you can see everything they're doing. You could spin it off into your own fork. They do provide step files, so you can edit these designs. You can play with the designs, and I believe the license is an open license, so you can do whatever you want with it. If you got some really good results and started showing this off a little bit more, you could probably reach out to Pollen Robotics and get some buy-in from them. They were just purchased by Hugging Face. Does anybody know who Hugging Face is?
I've heard the name.
So,
I don't know what it is.
Hugging Face is a gigantic repository of machine learning, AI, resources, all open source and free for anybody to use and access. So that, again, gets you into that open source community, and gets you access to some of these tools for doing more training, more teaching, gathering more data, maybe some platforms to start gathering some data to really lean into the AI and machine learning that's coming for all of our jobs. To teach these hands how to do stuff, you need lots of data. So they have some resources to kind of help you spin that up and figure out how to do that well. And I think e-NABLE has the number of people that could do that, right? So maybe this is the right platform. Get a bunch of people making amazing hands. I think you can actually buy the Amazing Hand kit now commercially from there's a couple sites where they'll sell you all the hardware.
One thing I just want to be cautious of as we talk about this is there's two separate things at play, right? One of them is the physical hand itself, and the other one is how the hand is controlled, and whether that control is, to Scholl's point, EKG, whether or through voice, or whether it's through mechanical. Those, I think we should kind of untether those a little bit, not entirely, but a little bit, because the work that's being done on EKG control should be able to be well adapted, independent of the hand it's controlling.
Yeah. So all of these control mechanisms doesn't matter, right? Who cares?
Well, that's why. Yeah, I was like, why not just pick one and then pick another, and then kind of supplement with the other if we can.
Yeah, it doesn't matter. I am agnostic to how you control the thing. And I think you want to write your software and segment it so that it is agnostic. You can plug and play, use whatever you want.
They can swap.
A la
That's
carte
right.
menu of whatever system works best, because one system won't work best for everybody. So
Right. But to David's point, I think it also makes sense to say, okay, for this particular
yeah,
vision, we're going to use this module of this kind, this module of this kind, this module of this kind, and if in
yeah,
such a way that if the B module turns out to be better done with AI, you can swap it in without having to affect A and C.
yeah.
Um,
So,
your
Eric,
discussion about
yeah.
VLA, which is a new term to me,
Mhm.
he immediately had me, remembering the Babinski reflex and the way, our bodies work. Um, if if you're a newborn or if you've had brain damage, if you touch, if someone touches your palm, your hand grips it. There are gripping reflexes. Um, Trapeze artists depend on them also. When they hit the bar, if they have their hand this way, their hands close immediately, whether they're thinking about it or not. And, a simple palm sensor of some sort that would simply by default cause the hand to grip would work for handshaking and bottle holding. And then there's just a question of what's the release mechanism. Maybe it's a quick wrist flip or something. But these are all interesting things to think about. Well,
See,
David, I hear
I,
you. Oh, sorry, Vivek, please.
I just had a quick technical question for Eric. So, Eric, just going back to this brave new juggernaut called AI and programming. So, you said you did some programming just using Chat GPT. I'm just
Mhm.
curious, how good is the code and how much tweaking and fixing do you have to do, and how does it all work? What do you put in?
So you kind of tell the GPT what you want to do. You have to have some base level knowledge of coding, some basics. You tell it what you want, and it'll spit out some code. And you can run that code, and maybe it'll work, maybe it won't. Uh, but then the nice thing is, if you know what you're doing and you really practice with it, you can kind of steer it to do what you need. Uh, the approach to take though is to build it in very, very small steps, right? I can't just go in and say I want a robotic hand that I can control and I want it to open and close and do all these things. You start at the very beginning. It is software engineering to some extent, where you have to know what your requirements are. You have to know what you're going to do and have an idea of how you're going to build and architect it. And then what the GPT does for me is usually it fixes any of the syntax things. Like I'm switching between C, C++, Fortran, Python, C sharp, all of these different languages. And I frankly forget, how do I run this function? What's the command to even print in Python? I forget it. And the GPT can just jump right to, this is how you say it in this language. So if you prompt it with exactly what you want to do, it can spit out that context, that syntax. And you can feed it.
But you,
Yeah, go for it.
so you use it like you would use a chatbot, like a large language model
Yeah,
for in you would
yeah.
describe the task. Okay.
Yep, you
Wow.
describe it in plain English. It's like a junior intern that is really good at knowing syntax. Um, but
In my
yeah.
experience, I'm using Claude, the top of the line these days.
Mhm.
Um, and in my experience, it's substantially better than a junior intern. It's certainly on web related stuff and on conceptual stuff. The whole logical and sequential planning, not so much. But if you give it a fairly well-defined task, especially something that someone has done somewhere, it does a remarkably good job. I can't resist showing you something I've been spending a ridiculous amount of time on in the last few weeks. But this is the Eco Restoration Alliance network. And, it's written in a language, it's written in JavaScript and HTML, And I vowed never to learn JavaScript 15 years ago, and I've never learned a JavaScript. And yet, here we have actually quite an interesting and robust system that, seems to work and is running on a GitHub page. And all of that, including all of those esoteric version control commands, is, oh, look, there's John Shull and his first order connections, his second order connections in this particular network, and his total connections. And, this is the kind of thing I've wanted to do for 15 years. And suddenly, and I'm not sure it's a good thing, I'm able to sort of realize these sort of mental models I've had for a long time. So Vivek, it's eminently playable with these days.
Wow.
But in
It's
fact,
great. It gives great results. It loses context very quickly.
Yeah,
So
that's the big problem these days. In truth, that's the real story, is you go from having a clever intern to having a really smart graduate student and programmer. And then at some point it regresses to high school level and you're starting over
So,
again.
Eric, just to close on one question that you had, that I had. So
Yeah.
in terms of what you might propose for the time being with for the immediate future with the physical hand as a test platform to zero focus on, would you say what you have now with the amazing hand is better than what you had built previously? I don't know
Yeah.
what it was, the kinetic hand or something, or
Yeah, so I played with the kinetic hand, I played with the Kwawu hand, played with all of those different hands. I think if you're willing to give up a finger, right? Because this is 4 fingers, so that's got to come into play as well. But if you're willing to do that, I plan to move forward with using this for projects if I want to do stuff.
Cool.
I think it's a good start.
So just to discuss further on the proposal we had, which David is now leading officially. Just kidding. Yeah,
Or David.
I think it's great to say that it's agnostic, hardware agnostic, and processor agnostic, and all that good stuff. But there should be a reference design, right? We should say the reference design is, the amazing hand, and the reference controller is I think you said the Pi. Yeah, Raspberry Pi is preferred, and EMG sensors from Meta, and you just give it a baseline set of options because you want people to focus on adding value, right, in terms of algorithms and making this hand useful for the community, for people, for real people. So I don't know if that makes sense in terms of how to structure this thing we're talking about.
It does. I think it does.
Yeah. My approach would be use the amazing hand as the hardware and use a Raspberry Pi as the software. And then you can build whatever you want on top of that.
Just a quick question. I also see from the same folks, there's a Ruka hand. Have you used that by any chance?
I haven't seen the Ruka hand. Where is that? How do you spell that?
RUKA. I personally, mechanically, do not love it, just because it's passive spring tension. So you're going to lose a lot of force. You're going to lose a lot of force, right? Because you're pulling against a increasingly harder spring every time.
Yeah, I have seen this one. I don't like this one either. What I don't like is they've got all the servos enclosed in this giant thing that's on the wrist, right? That is not something that you can take and put onto a person. This is much closer. You've got the servos inside of the hand. You've got a little bit of wiring. I can see the path for this to be something that can be used on a person. I don't see the Ruka hand something that could be used on a person. And their costs are $1,300 and 8 hours to assemble. Yeah, I did see this one pop up and I was like, I see it for robotics, great for robotics, because they're spending $20,000 on a end effector. They don't care. I do. It's weird. I go into work, and do you know the modular prosthetic limb?
I'm not familiar. No.
The MPL. So this is Johnny. Oh gosh, what's his name? It's the most
Oh,
advanced prosthetic in the world, right? They developed it for DARPA years and years
Oh,
ago.
yes,
Several
yes.
million. There are 7 of them.
huh,
They were several $1 million each, and right now they're just sitting around in a lab. I walk by them every
really?
day and just see it sitting there, and it's like, that
Is that the
doesn't
one
look
that
that
Dean
much
Dean Kamen was
better.
involved with?
I think so. Lots of people were in on it.
Wow.
Yeah, I have a good story that I've told John about this, that like the best product that I've ever brought to market, with the highest longest adoption with continuous use, was a sweatband with a piece of Velcro, because it was 100% washable. There was no failure
Right.
mode. It was completely safe.
Yeah.
Um, if I don't know what your bandwidth is, I don't want to volunteer you to help with this, but I can champion all of the mechanical and most of the hardware and almost none of the software. Um,
I can do some stuff. My bandwidth ebbs and flows.
do you want to meet 2 of us offline to discuss? How's that?
Yeah, potentially. Usually on weekends, my
Yeah.
days are pretty full. It's pretty much I get into work at 8 and then I get home at like 8. Uh, it's busy.
My experience with these types of things is that, to John's point, you need a few people who understand the landscape and who can manage the tasks and make architecture decisions, and then can help organize people to carry out the tasks, but don't often have to do all of the task doing themselves.
Yeah. What I can try to do is what I think really needs to be done is probably I need to document this. I need to fork the amazing hand and just spit all this up with a guide for how to install it all.
I sent you my contact info. We can chat offline.
Cool.
A couple of observations. First of all, thanks so much. And you know, I think this particular charge up a hill might actually succeed. Would certainly be interesting. So I'd be interested in certainly supporting it, but maybe participating also. I can tell you that um, th with regard to documenting this, I have found that the closest thing we have to a solution to the losing context problem with AI, which is probably going to be the way you solve your software handicap, David, is you have the AIs write the documentation. You say specifically, you need to explain everything that you need in order to be able to regain context if your buffer overflows. And it needs coaching on how to do that. But I have found that once you've got, and it's perfectly capable of writing voluminous documentation, once it's got concise but well-designed documentation, I'm able to say, look, you've forgotten everything, damn it. Read these files. And it says, okay, I've got the big picture now. Shall we continue? And it works.
Yeah.
So, with that kind of documentation and architecture, I don't know if you need a coder these days, David.
I don't know. I don't know. I spent my entire career
Okay.
trying to trying to stay out of software unsuccessfully, but
Oh, wise. I am now a software engineer and I never wanted to be. Ugh, it's horrible.
Interesting.
Um,
I
Interesting.
was a software engineer for a huge chunk of my life, but I just can't put my arms around this whole generative AI for software, because I keep seeing articles about how people say there's so much rewriting to be done that you might as well have a actual coder do the whole thing. But I'm behind the times, frankly, so
I
that
don't
doesn't
buy
matter.
that. I am working with really world-class software engineers and I just snuck in. and the code that they're writing is no different, no better documented than anything else that I'm seeing AI do. I think it's a lot of software engineers that are like, this is going to take my job. I'm better than this. I can do this faster myself. And great if you can do that. But the code they are producing and sending to me that I'm looking at, it is not well documented. It is not clear. They're not nearly as good as they say they are. So I don't put as much stock into the AI is terrible and I have to just rewrite everything. But the caveat, I'm not doing secure code
Mm,
things. I'm doing small projects, quick prototypes. I'm not having it write a huge code base. This is so
Right, right.
I think that's the difference.
These are mostly reports I've read. I don't frankly have any direct experience.
Yeah,
Um, I think
I don't trust those
I
reports.
think it's also in how well it works, right? It's not more than just the documentation, how well it actually does it actually work.
Yeah,
But yeah, you're right. I mean, this is a whole revolution.
yeah.
right. So as you can see, I'm afraid I've gotten sucked into this now, and I'm sort of up to speed with the challenges and the solutions at this particular level of so I'm not developing models. I'm using these models as programming the way I would hire a good programmer. Suddenly I've got a good programmer who works for $5 an hour. And I find that every time it's time to put another $10 into the pot, I have no hesitation to do it. If Vivek, you're a former software engineer, so you understand the kinds of things that go on under the hood. With that kind of understanding, you're often able to coach and interpret um, what the AI is doing without even taking a deep look at the code. You can say, look, obviously you've got some kind of an array of data here, but you should access it by ID instead of this, that, and the other. And it says,
You're,
oh,
you're,
that's a brilliant idea, says the AI. And then it'll say, hey, how about this? So if you'd
I
like
admit
a
this whole
walkthrough, I can show you some interesting tools, and then you might become the software um, component of this team.
I yeah, I admit this whole revolution has gone by me like at warp speed. So, but I would on a separate note, I can help out David and Eric on the sensors side. I spent
Hmm.
most of my career on sensors, mostly industrial sensors, but it I can look at stuff or whatever, uh, offer my 5 cents. So, be glad to contribute there.
All good.
I sent Vivek and Eric, I sent my email in the chat. So just if you guys send me a message, we can set up some time to discuss, three of us, and see what this looks like. I think it's tricky to do something that is sustainable and also like continuous. But I feel like I've seen enough of these go
Hmm.
well and poorly.
Well, the other thing, David, is to try to find, the minimally viable product, the smallest possible thing that would be functional enough to hold together and attract people.
I agree.
Um, the grand vision is usually a trap.
I agree. Okay.
Cool.
I will
Eric's. Oh, sorry. Go
also specify the caveat that in the new job, my employer owns everything.
Hmm.
They own me. They own anything I do, even on my own spare time.
Oh, wow.
So I do have to discuss with them and get permission to
Okay.
post some stuff. It shouldn't be a problem. There are lots of people that do contribute to open source projects in their spare time.
Cool.
I
Cool.
just have to run it through the pipeline and get a permission to post up a fork to GitHub. Basically, that might
Very
take a
good.
little bit of time.
Okay.
Okay.
So now that we're
Eric, I'm so
actually,
glad you're still with us. You've been a mainstay.
yeah, I try when I have time.
Eric, is it okay if I reach out to you in, let's say, a month?
Yeah,
Okay.
no problem.
Just send me your contact info and I'll
Yeah, you should have an email from me.
Oh, okay, perfect.
Yeah,
Nice.
Like
just
a minute ago.
FYI, David, I'll be out of December. Going to
Okay.
be in India for a whole month, so
Ooh,
That sounds pretty good. All
But I'll
right.
bet you still
exciting.
get email. If you CC
oh yeah.
Vivek, he can become the institutional memory.
That's true.
While we're on the call, I know we're out of time, but for the next Bionics meeting, John, you had suggested you had mentioned this guy Ricardo Torres. He's doing something with Bionics. Did we want him to talk or?
Vivek, I think I must have forwarded you something that seemed interesting. I don't even remember what it is, but
Okay. In
that's all I
in any
got.
case, Sarah, I won't be around December, but if you want to
Ah,
resume in January, we could try to get him. I can try to get him,
cool.
but you guys can keep going. There's no need to stop with the forum meetings.
Very good.
Okay.
Thank you, everybody. Great to see you all.
Thanks. Thanks, Eric.
Bye.
Thanks for your time.